Hello everyone, my name is Yao Junkai, and this is my midterm project for the introduction of computer science. The problem, I've designed a problem that the error rate for BPSK signal transmission, and the BPSK means the binary phase shift keying. Imagine sending a huge message like 1 million tiny bits of data through your phone or Wi-Fi. Sometimes noise like static on the radio mess up the bits, causing errors, and our Python program pretends to send these bits and find the first 10 errors. Here's how it does. First, asks you to type a number called SNR, which shows it how clear your signal is compared to noise. A bigger number, like 5, means a clearer signal. And make sure you type a real number like 0 or 5 and ask again if you type something like ABC. And figures out how likely errors are based on your SNR. And pretends to send 1 million bits and noise the first time an error happened, remembering which bits number went wrong. And finally, show your SNR error chance and where each error happened. Okay, so we're going to talk about the background knowledge for BPSK. Uh, the how data gets sent, like when you use Wi-Fi, and we're using BPSK, which turns bits 0 and 1s into waves. One become one kind of waves, and 0 become a wave with a different random. Alright, so look at the S1 and S2. These waves travels to receiver like your phone. Alright, but noise like static on the radio can mess things up. And look at the right side, the right figures, and the receiver gets the wave plus noise, so it has to guess is it a 1 or a 0. Okay. And if the noise is too strong, it might guess wrong, causing an error. The chance of error, called the bit error rate or BR, depends on how clear the signal is compared to the noise, called SNR. And so a higher SNR like 5 means a clearer signal and fewer error. A low SNR like 0 means more noise and more error. The noise has a content strong that can confuse the signal. Okay. This is the error rate for BPSK. It will have many kinds of PSK, not only for BPSK. It might have MSK, QPSK, but we only talk about BPSK in this program. So now, let's look at the Python code. We're starting by loading two tools, random to create random error, like flipping a coin, and math for random number calculation. We'll set up the basis. We will send 1 million bits, look for the first 10 error, and use a random seed 42 to make the result recomplicated. The program asks you to type an SNR number like 0 or 5. It uses a try escape chance to make sure you type a number. If you type something wrong, it shows an error message and stop. Next, invert your SNR number into a form we can use to calculate an error chance. A higher SNR means fewer errors. The error chance, called BR, is figured out with a simple formula that makes errors less likely for clearer signals. We'll set up two things, a counter for errors and a list to remember where errors happen. The main part uses a for and a loop to get through all 1 million bits and one by one. For each bit, we'll roll a random number. If it less than the error chance, we'll say, oops, it's an error, and add 1 to our error count. Then save the bit error then the bit number where the error happened, and stop after 10 errors. Finally, we'll show the result using the style. Okay. So this is what happened when we run the code. If we type SNR10, the error chance is about 0.0000023, so it's very small. And for each error, it will tell you which bit went wrong and how many bits went so far. And if we get the larger SNR, the BR went smaller. So if you type too large SNR, and so you have to let the let the symbol times get larger, so it can run 10 error, or it won't get out the conclusion. So that is our project. We use Python to pretend we are sending data like a phone message and counted error caused by noise. We learn about signals, noise, and how to use loops and decision in Python to check errors. This project is a fun way to see how coding connects to real-world tech, even if you are now new to it. Okay, thank you for watching, and I hope you enjoyed learning from this.